This is an introduction to the total station exercise, which will be broken up into 3 parts. The first, how to find true north. Given 2 known locations, point A and point B, how can we find true north? The first tool we will need for this section is the total station, which will be placed at point A. The second tool is a prism, which will be placed at point B. Switching to the top view, the distance between point A and point B is D1. If we do know the north direction, bearing beta is as shown. Think of D1 as the hypotenuse of a triangle with the sides delta N and delta E. D1 is calculated with the horizontal distance formula. D1 is equal to the square root of delta N squared plus delta E squared. If we know the coordinates of point A and point B, delta N is equal to the northing of B minus the northing of A. And delta E is equal to the easting of B minus the easting of A. The change in northing and easting can calculate beta, which is equal to the inverse tangent of delta E over delta N. The second section is how to find a point of interest. Given 2 known coordinates, point A and point B, how can we find the coordinates of the third point C? The necessary tools for this section will be the total station, which can be placed at either point A or point B as both are known, and 2 prisms, one placed at point C and one placed at the remaining point, in this case point B. Looking at the top view, the horizontal distance to point B and C are D1 and D2. The total station is used to measure alpha, the angle BAC. The 3 coordinates of point C can be calculated. The northing of C is equal to the northing of A plus delta N. The easting of C is equal to the easting of A plus delta E. And the elevation of C is equal to the elevation of A minus delta Z. Looking at the profile view, D2 isn't the hypotenuse of the triangle, but the base. The total station can find the vertical angle, theta. The elevation from point A to point C, delta Z, can be calculated. Delta Z is equal to D2 times the tangent of theta. Using the triangle rule, 2 identical triangles exist and can be used to calculate the coordinates of point C. Using trigonometric identities, delta N and delta E are calculated. Delta N is equal to D2 times the cosine of bearing C. Delta E is equal to D2 times the sine of bearing C. Delta N, delta E, and delta Z can be calculated relative to point A or point B and can be checked using the Pythagorean theorem. The third section is how to find the location of the total station. Given 2 known coordinates, point B and point C, how can we find the coordinates of a third point A? A tool necessary for this section will be the total station, which will be placed at point A, as well as 2 prisms, which will be placed at point B and point C. Looking at the top view, the horizontal distance to point B and point C are D1 and D2. The total station is used to measure alpha 3, the angle BAC. Using the horizontal distance formula, D3 is equal to the square root of delta N BC squared plus delta E BC squared. Using the law of sines, the sine of alpha 3 divided by D3 is equal to the sine of alpha 1 divided by D1, which is equal to the sine of alpha 2 divided by D2. The bearing between B and C, or C and B, beta BC, is either beta C equal to the inverse tangent of delta EBC divided by delta NBC, or beta B is equal to the inverse tangent of delta E CB divided by delta N CB. Using point B, bearing A is equivalent to alpha 2 plus bearing C. Using point C, bearing A is equivalent to 180 minus the total of alpha 3 plus alpha 1 minus bearing B. Using the triangle rule, two identical triangles exist and can be used to calculate the coordinates of point A. Using trigonometric identities, delta n and delta e are calculated. Delta n is equal to d1 times the cosine of beta a, and delta e is equal to d1 times the sine of beta a. The elevation from point A to point C, delta z, can be calculated. Delta z is equal to d2 times the tangent of beta. Using calculated delta n, delta e, and delta z, the coordinates of A are the northing of A equal to the northing of B minus delta n, the easting of A, which is equal to the easting of B minus delta E, and the elevation of A, which is equal to the elevation of C plus delta z. Delta n, delta E, and delta z can be calculated relative to point B or point C and can be checked using the Pythagorean theorem.